A mysterious exoplanet may be rewriting our entire understanding of the universe, potentially overturning humanity's centuries-old belief that we are alone in this vast solitude. This past April 17th, NASA released some truly shocking data. Scientists have discovered signs of life on a distant planet, and they've calculated the probability to be as high as 99.7%. Not only that, but this planet might also feature suitable temperatures, deep liquid oceans, a thick atmosphere, and a stable climate. This is no longer just a second Earth from a science fiction novel. This is a truly habitable candidate planet, backed by hard technology and data. If life truly exists there, it could be a life form completely different from anything we see in Earth's organisms. So we have to ask, are these life forms simple microbes? Or are they intelligent civilizations that have evolved over billions of years? Does this mean humanity is finally no longer alone? Have we at last found another us in the vast, empty universe? Under that distant starry sky, is there some civilization silently observing us right now? What secrets are hidden in that far-off place? Back in 2015, the Kepler telescope restarted its K2 mission and began to deeply scan the cosmos once again. During this mission, it discovered over 1,200 exoplanets. Among them, one planet specifically caught the attention of the scientific community, a mysterious world with incredible potential habitability. This planet is roughly 2.5 times the size of Earth and possesses 9 times the mass of our homeworld. The astronomical community officially named it K2-18b. In 2017, the Spitzer Space Telescope joined the research efforts and confirmed that K2-18b is located firmly within the habitable zone. This is that ideal zone where liquid water could theoretically exist on the surface. At the same time, an observatory in Chile utilized a spectrometer to determine the planet's density. The resulting data indicated it might possess a vast global ocean. Hope began to rise. More and more signs started to suggest that life might actually exist on this planet. In 2019, the Hubble Space Telescope brought even more new discoveries to the table. Water vapor was detected in K2-18b's atmosphere. The idea that it might have deep oceans and support life was no longer just a fantasy. In 2023, the James Webb Space Telescope began its own observations and detected traces of dimethyl sulfide and dimethyl disulfide in K2-18b's atmosphere. This is a special compound that is almost exclusively produced by living organisms on Earth, such as phytoplankton and various marine microorganisms. If this discovery is true, it would mean humanity may have discovered concrete evidence of extraterrestrial life for the very first time in history. However, science requires extreme caution. Since the initial data came only from the Webb telescope's near-infrared camera, and in that specific wavelength band, the signals of dimethyl sulfide and methane are easily confused with one another. Because of this, scientists had to raise reasonable doubts. Could it be an instrument malfunction, or perhaps just a measurement error? Therefore, NASA decided to conduct more rigorous verification by repeating the observations using different instruments and different methods. Only when different equipment and methods yield the exact same results can it be called a true verified scientific discovery. On April 17, 2025, the Webb telescope used its new mid-infrared camera to scan K2-18b in detail, once again. The result was the redetection of dimethyl sulfide and dimethyl disulfide. Their concentration was found to be even 1,000 times higher than what we see on Earth. This is no ordinary gas. On Earth, dimethyl sulfide is an extremely unstable gas that evaporates very quickly. If you've ever walked along the beach in the evening breeze, that unique ocean smell you recognize is actually its scent. Given that this gas is extremely unstable in an atmosphere and very short-lived, it means it must be constantly replenished by something on the surface. If its source is indeed biological activity, just like it is here on Earth, then there's only one reasonable explanation. Life exists on K2-18b, and it exists on a massive scale sufficient to continuously produce this gas in huge quantities. This discovery is precisely why the entire scientific community is so shocked right now. Detecting such faint gas components from 124 light-years away sounds a bit like science fiction, but The Webb telescope has indeed achieved this. Whenever K2-18b passes in front of its star, some of that starlight penetrates the planet's atmosphere. Although this light is faint, it carries incredibly valuable information. Because different atmospheric components absorb light at different wavelengths, they leave unique fingerprints in the light's path. The telescope captures these subtle changes and transmits them back to Earth, allowing astronomers to analyze the chemical composition of that atmosphere. In other words, scientists are reading the gas composition of this distant planet simply by looking through the star's light. However, to truly understand the potential of K2-18b, we must also look at its specific astronomical environment. This planet orbits the red dwarf star K2-18 and is located about 124 light years from Earth. It's actually very close to its parent star, only 2.5 times the distance from Mercury to our Sun. However, since K2-18 is much smaller than the Sun, colder and dimmer, K2-18b receives almost the same amount of energy as Earth does. This is one of the primary reasons it is classified as a habitable planet. This world is classified as a hypothetical Hycean planet. This term is a combination of hydrogen and ocean, used to describe a planet enveloped by a thick hydrogen atmosphere and covered by deep global oceans. This theory was first proposed back in 2021. Furthermore, observations also found almost no ammonia in its atmosphere. This further supports the speculation that it might possess liquid water, because ammonia is easily absorbed and dissolved by large bodies of water and does not typically remain in the atmosphere for very long. Although all these signs are exciting, the situation is not without controversy. If K2-18b is indeed covered by oceans, its temperature might be too scorching, with extreme atmospheric pressure and chemical conditions that could turn it into a boiling, deep-sea hell, making it difficult for any life to survive. Furthermore, some researchers argue that this planet might not be an ocean world at all, but rather a mini Neptune, a miniature gas planet. For example, NASA's Nicholas Wogan believes that K2-18b likely lacks a solid surface and is much more similar to a mini Neptune. If this is the case, then the possibility of life existing there is almost zero. However, the lead researcher of the project, Niku Madhusudhan, remains optimistic. His team was the first to detect those signs of dimethyl sulfide, DMS, and they firmly believe K2-18b has oceans and may even harbor abundant life forms. Madhusudhan has stated that within the next 1 to 2 years, the scientific community will be able to confirm with 100% accuracy whether dimethyl sulfide truly exists there and determine if it is a product of biological activity or some other natural process. Currently, according to scientists' estimates, the possibility of finding signs of life in K2-18b's atmosphere is as high as 99.7%. This is humanity's highest confidence record to date in the search for extraterrestrial life. In statistical science, this probability is known as 3 sigma, meaning the result has a 99.7% confidence level. In contrast, earlier observation data only showed 1 sigma, with a confidence level of just 68%, which is far from being a reliable basis. However, in the scientific community, for discovery to be fully confirmed, it usually must reach a 5 sigma confidence level. That means 99.99994% accuracy, with an error rate of only 1 in 1 million. For example, the 2012 announcement of the discovery of the Higgs boson used this 5 sigma confidence level. Scientists are now making equally stringent demands for the data coming from K2-18b, although this discovery is highly appealing. The research team at Cambridge University still emphasizes that it's far too early to announce a major breakthrough. To truly assert that K2-18b harbors life, first, researchers must confirm the presence of dimethyl sulfide in the planet's atmosphere using that 5 sigma standard. Second, it must be proven that this gas indeed originates from biological activity, just as it does on Earth. If all these conditions can be successfully verified, then you will witness an unprecedented breakthrough, humanity's first concrete evidence of extraterrestrial life. Perhaps even more astonishing than the existence of life itself is exactly where it might exist. K2-18b is only 124 light-years from Earth, which is approximately 1.175 quadrillion kilometers. For us humans, this distance is almost unfathomable. Even sending humans to Mars is still a massive challenge, let alone interstellar travel. Such a journey might forever remain in the realm of fantasy for us. However, on a cosmic scale, 124 light-years is actually negligible. The observable universe spans about 93 billion light-years. If life is indeed discovered on a planet just 124 light-years from Earth, it would be like traveling the world to find an answer, only to discover it was hidden in a corner of your own pantry the whole time. If life is ultimately found on such a nearby planet, it would mean that life not only exists, but might even be very common throughout the universe. While all of this is currently speculation and research continues, one thing is certain. Humanity has never been closer to answering the ultimate question. Are we alone? While awaiting a definitive answer, you might as well imagine, what if that distant planet truly harbors life? What would they look like? Let's start with the simplest forms. Just like on Earth, the origin of life often begins with microorganisms. K2-18b's potential life forms might be microbes that survive in high temperature, high pressure, hydrogen-rich environments, similar to the extremophiles found around Earth's deep sea hydrothermal vents. These life forms would not rely on sunlight, but rather obtain their energy through chemical reactions, such as the oxidation of hydrogen sulfide. Given K2-18b's hydrogen-rich atmosphere and likely volcanic activity, this kind of chemical energy should be very abundant. If life has progressed further there, evolving into multicellular or even complex life, you would witness an extraordinary spectacle, completely different from Earth's ecosystems. In a deep-sea world enveloped by a thick atmosphere, light would barely penetrate to the depths. Vision would likely not be the primary mode of perception for these creatures. Just like deep-sea creatures on Earth, life forms there might rely on vibrations, heat sources, magnetic fields, or chemical signals to sense their world. Some might also evolve bioluminescent abilities, like fireflies or anglerfish on Earth, emitting a faint glow in the darkness. Most fascinatingly, in a low-density, hydrogen-rich environment, the increased buoyancy could allow these creatures to be larger than any species we have on Earth. Moving slowly, they would possess massive bodies perfectly adapted to high-pressure environments. They might resemble giant jellyfish or amorphous organisms floating freely in those warm oceans or thick atmospheres. Whatever their form, it's certain that in that environment so different from Earth, every life form must face unimaginable pressure and temperature and transform them into instincts for survival. The oceans of K2-18b may be much deeper than those on Earth. If abundant life forms indeed exist here, some might inhabit depths of 16 to 24 kilometers below the seabed, far exceeding Earth's deepest point in the Mariana Trench. Creatures surviving in such extreme environments may possess special body structures capable of withstanding that immense pressure. The most intuitive idea is that they may have evolved hard yet elastic shell structures to effectively protect their internal organs from being crushed. Additionally, the skeletons of these creatures might be composed of robust biopolymers that are several times stronger than the biomaterials used by life on Earth. You can imagine a crab-like exoskeleton structure, but with much higher density and greater strength, resistant to being deformed by the high pressure. Their bodies could be covered in tough biological scales or natural armor that combines flexibility with raw strength. Of course, all of this is still speculation. We don't know what sustains these hypothetical life forms or whether they possess a genetic system similar to Earth's DNA. However, if the previously detected dimethyl sulfide was indeed produced by living organisms, it suggests that life not only exists there, but has successfully adapted to the extreme environment of this planet. No one can be sure, but perhaps at this very moment, in the warm and dark deep sea of that distant planet, certain creatures are slowly moving, and our Earth is just as alien and out of reach for them as they are for us. Although K2-18b is currently the most promising candidate for finding alien life, it's not our only hope. Now, Let's look at another equally fascinating exoplanet, T-Garden Star B. T-Garden Star B is about 12.5 light years from Earth, which makes it almost our next door neighbor by cosmic standards. Scientists estimate that this planet has approximately a 60% chance of having Earth-like conditions, including mild temperatures between 0 and 50 degrees Celsius, the presence of liquid water, and a relatively stable climate system. However, the key premise is that these habitable conditions may only exist in a very narrow region, the terminator zone, where day meets night. This is because the planet is likely tidally locked, always facing its star with one side. This means one side is perpetually in scorching daylight, while the other is plunged into an endless frozen night. Consequently, a massive temperature difference will form on the planet's surface. The day side will be scorching hot, and the night side will be extremely cold. However, in that narrow zone between these two extremes, there might be a mild climate in a water-rich terminator region. There, liquid water might exist stably, and life might quietly emerge or even evolve into complex multicellular organisms. Another fascinating planet that could harbor life is Kepler-1649c, which was discovered in 2020. It's about 301 light years from Earth. Although it's quite distant, it possesses several intriguing features. It orbits a small, dim red dwarf star with a mass that is only 1/5 that of our Sun and a volume just 1/4 of our Sun's. Therefore, this planet receives about 25% of the light and heat that Earth does. Kepler-1649c's radius is 6% larger than Earth's, and its mass is 20% greater. This means its surface gravity would feel very similar to what humans experience here, neither too strong nor too weak. However, just like T-Garden Star B, it might be in a tidally locked state. In the terminator zone between the extremes of perpetual day and night, there might also be a mild and stable climate zone with temperature conditions and liquid water similar to Earth's. Perhaps beneath this eternal twilight, some form of primitive life is quietly existing right now. Another candidate planet worth noting, also discovered in 2020, is K2-18b. It's about 101 light years from Earth. It is the third outermost planet in its star system, and is possibly the most suitable for life that we've found so far. Unlike Kepler-1649c and T-Garden Star B, K2-17b may not be tidally locked. This means it would experience regular day and night cycles like Earth, thus having a more stable and life-friendly climate overall. K2-17b receives about 86% of the light intensity from its star compared to what Earth receives from the Sun. Although that's slightly lower, it is more than sufficient. According to model estimations, the surface temperature of this planet is about -4 degrees Celsius. While that sounds cold, it's not extreme. Even with a weak greenhouse effect, the environment could become much milder and more comfortable. In terms of size, K2-17b is slightly larger than Earth, with a slightly higher mass and slightly stronger gravity, but it's still well within the habitable range. More importantly, its host star is unusually calm. It doesn't frequently erupt with flares or release high-energy particle streams like most red dwarfs do. Such a mild stellar environment helps maintain the stability and longevity of the planet's atmosphere, and may even give rise to oceans, which could then foster life. While the exact surface conditions of K2-17b remain uncertain, a growing body of evidence suggests it is steadily moving up the list of exoplanets with real potential for life. Not all of these intriguing exoplanets are similar to Earth, though. Some planets seem to have come straight out of a science fiction movie. J1407b is one of the most bizarre among them. This mysterious planet is located about 434 light years from Earth. Its existence is like a super version of Saturn. Scientists still find it difficult to measure its exact mass, but it is generally estimated to be about 10 to 40 times the mass of Jupiter, and its volume far exceeds that of the largest planet in our solar system. However, what truly makes your jaw drop is its incredibly vast planetary ring system. This system is composed of 30 stellar rings, each millions of kilometers wide. According to rough estimates, the diameter of its complete ring system can reach 180 million kilometers. That's 200 times the Saturn's ring system. If Saturn had such an exaggerated ring system, it would almost cover half the sky at night, becoming the largest visible cosmic object to the human eye. Unfortunately, such a sight cannot last forever. As time passes, multiple moons will gradually form around the planet, and these rings will eventually thin out or even disintegrate entirely. And this is just the prelude to the strange worlds found in the universe. Some planets are hotter than the sun, some are larger than their host stars, and there are even planets with the density of marshmallows. The universe's imagination far exceeds that of humans. Next, let's explore some of those incredible alien worlds, such as GJ504b, located 57 light years from Earth. Its mass is 4 times that of Jupiter, and its volume is almost comparable to Jupiter's. However, the most bizarre thing about it is that it's pink. Why does it have such an unusual color? Scientists speculate that this color may stem from its age. This planetary system is only 160 million years old. In contrast, our solar system is 4.6 billion years old. Because it is still radiating the heat from its initial formation, the planet exhibits a faint reddish or pinkish glow, like an uncooled star softly shining in the night sky. Of course, the universe's oddities go far beyond mere colors. There are also some water-rich planets, like the water world version of a Neptune-like planet. This type of planet has a mass more than 8 times that of Earth and a radius about 1/4 of Jupiter's. At first glance, it might seem that such a planet is well suited for life, but in reality, it's not. Such planets have no solid surface, and their atmospheric composition is completely different from Earth's. Due to extreme high temperatures and pressures, the water here no longer exists in liquid or gaseous states as we know them, but rather in a mysterious form called a supercritical state. In this state, water is no longer clearly divided into gas, liquid, or solid. It is a strange form somewhere in between a liquid and a gas. This ambiguous in-between state seems like another life form for water itself, making such planets appear exceptionally alien and mysterious. Despite temperatures reaching 280 degrees Celsius, the water won't evaporate or condense in the ways you're familiar with. Instead, it continuously maintains this vague, undefined state. Now, let's turn our attention to the constellation Cygnus. There, 3,800 light-years from Earth, exists an exceptionally hot planet called Kepler-7b. This planet is very peculiar. Its mass is only 44% of Earth's, and its radius is 75% of Earth's. Yet, it is one of the hottest exoplanets known to date. Its host star was once a main sequence star, much like our Sun, and the planet itself was once a gas giant, similar to Jupiter. However, about 18.5 million years ago, the host star entered its red giant phase, and its volume dramatically expanded. As a result, it engulfed most of the planet into the star's interior. Ultimately, only the scorching iron core survived the ordeal. Scientists believe this planet is still continuously evaporating and may shrink even further in the future, because Kepler-7b is only 0.006 astronomical units from its star 65 times closer than Mercury is. To the Sun, the surface temperature of this planet reaches a staggering 6,650 degrees Celsius. This is more than 1,000 degrees hotter than the surface of the Sun itself. If hell truly exists, it's probably on this planet, but there are even more outrageous existences out there. For example, JWST P76b is another equally hot planet, located 640 light-years away. WASP P76b was discovered in 2016. Its mass is almost equivalent to Jupiter's, but this planet is famous not just for its temperature, but for the fact that it's where iron rain falls. Due to its synchronous rotation with its star, one side always faces the star, creating eternal day and eternal night. The dayside temperature can reach 2,350 degrees Celsius, which is hot enough to directly evaporate iron into the atmosphere. Coupled with radiation thousands of times stronger than Earth's, the environment is extremely harsh. On the night side, the temperature is less than half that of the day side. Due to this vast temperature difference, The planet has an extreme storm system that blows hot iron vapor from the fiery side over to the dark side. There, the vapor condenses into liquid, and that's exactly how iron rain falls. Isn't that wild enough? But there are even more wondrous and incredible planets. Consider PSR J1719-1438b. What makes this planet so special is that it's 3,000 times larger than its parent star. Its parent star is a neutron star, only 20 kilometers in size, but extremely dense. Even a single teaspoon of neutron star material would weigh billions of tons. Not only that, this neutron star is also a millisecond pulsar, rotating once every 5.4 milliseconds, which means it spins tens of thousands of times per minute, constantly emitting intense, high-energy radiation into space. P.S. RJ1719-1438b is an ultra-dense planet. Although its mass is similar to Jupiter's, its density is 20 times greater than Jupiter's. This is because it was once a star itself. Due to its close proximity to the pulsar, its outer layers were completely stripped away, leaving only a carbon-rich core behind. This remnant core was reclassified as a planet, and it is the diamond planet we see today. The universe seems to be teeming with all sorts of strange exoplanets. Some are so outlandish, it's hard to believe they truly exist. For instance, there's a planet named JWST that has a density similar to a marshmallow. This planet is about the same size as Jupiter, but its mass is only 30 times that of Earth. To put that in perspective, Jupiter has a mass 300 times that of Earth. Furthermore, its core is only about 4 times the size of Earth's core. Normally, for such a massive gas giant, its core should be at least 10 times larger than Earth's. Because of this, WSP-107b is practically like a giant marshmallow floating in space. This discovery has forced scientists to completely re-examine the formation mechanisms of gas giants. Of course, so far, these bizarre planets don't seem very suitable for human habitation. But there is one planet that looks quite promising, Gliese 581d. Finding a planet suitable for life is not easy, and most candidate planets are simply too far away from us. In contrast, Gliese 581d is less than 20 light years from Earth. Its mass is 6 times that of Earth, and it's located firmly in its parent star's habitable zone. Its surface temperature might be sufficient to maintain liquid water. However, due to tidal locking, one side of it is always day, and the other side is always night. But it's not as bad as you might think, because this planet has a very thick carbon dioxide atmosphere. This could potentially keep the night side from completely freezing over. Earth life is accustomed to the rhythm of day and night. However, whether life can survive under such extreme conditions on Gliese 581d remains unknown. If humanity ever colonizes this planet, the most ideal living area might be the Terminator Zone, where day meets night. Here, the temperature is moderate, and it's never completely dark nor scorching hot. It would be a life fissure belonging to a brand new world. Of course, the vastness of the universe far exceeds our imagination. An exoplanet named 2MASS J2126 is a vivid example of this. It was once thought to be a lone rogue planet with no companion stars, just wandering aimlessly through the star field. Later, scientists discovered that it actually wanders through space with a star called TYC94869271. Both of these celestial bodies had long been cataloged by astronomers, but no one ever realized they were connected until recently. One day, researchers found that both were approximately 104 light years away, and their orbital connection gradually came to light. Further observations showed that 2MASS J2126 orbits its star in an extremely distant orbit. The distance between them is about 1 trillion kilometers, which is equivalent to 7,000 times the Earth-Sun distance. This makes it the planet with the most distant known orbital radius. In such an orbit, this planet takes about 900,000 Earth years just to complete one single orbit around its parent star. In other words, in that distant world, 1 year is almost equal to the entire history of human civilization, plus the sum of all our future fantasies. Now, let's briefly turn our attention back to our own solar system. As we all know, Jupiter, the largest planet in our solar system, has 79 moons. Logically, then exoplanets should also have their own. However, for years, scientists were unable to find any conclusive evidence of exomoons. Until recently, the situation finally saw a breakthrough. To search for moons orbiting exoplanets in the vast universe is as difficult as finding a specific grain of sand in a massive desert. But scientists have still made some remarkable progress. Although they haven't directly found exomoons yet, they've discovered something even more exciting. For the first time, humanity has discovered a circumplanetary disk around a distant exoplanet. This planet is named PDS 70c. Using the Atacama Large Millimeter Submillimeter Array Telescope, scientists observed a dust disk orbiting this giant planet. This dust disk contains enough material to theoretically form 3 moons comparable in size to Earth's moon. This time, the discovery isn't based on computer simulations, but on a real-time observation of moons being born. This is a historic moment for astronomy. The last exoplanet to be mentioned is K2-18b. This planet itself isn't particularly special, but the peculiar star system it's in is very unique. Its size is only about half that of Saturn. When it was first discovered, scientists set it aside because the system was simply too complex to analyze. It wasn't until 10 years later that the scientific community revisited it and uncovered an astonishing fact. It's a triple star system. K2-18b orbits star A, and star A itself has a companion star, star B. These two stars orbit each other every 30 years. The entire binary system then forms a triple star system with a more distant star, star C orbits A and B once every 400 years. If one day you could travel by spacecraft to the edge of this planet's atmosphere and gaze out, you would witness a truly peculiar sight. Beneath you might be thick, brownish gray clouds, and above you, 2 distinct suns. One is 17% larger than our sun, while the other's brightness is only 0.5% of our sun's. Even so, its brightness would still be 1,000 times that of a full moon on Earth. These extraterrestrial realms, though bizarre, are not the most peculiar entities created by the universe. Scientists have even conceived of a more extreme planet, a black hole planet. These hypothetical celestial bodies might form from dust and gas clouds around black holes, originating the gravitational abyss at the edge of supermassive black holes. They orbit the black hole at astonishing distances, with orbits possibly taking millions of years to complete. The boundaries of the universe are not only found in spatial distance, but also at the very limits of our imagination. Astronomers are constantly discovering incredible celestial bodies, and each new discovery challenges our fundamental understanding of the universe. Consider that it took humanity centuries just to fully understand the planets in our own solar system, and they still occasionally surprise us today. So, with over 5,000 known exoplanets today, how much more is still unknown, just waiting to be discovered? Thank you for watching this video. If you like this kind of deep dive into the cosmos, please consider hitting the like, share, and subscribe buttons to support us. See you in the next one.